Hello, everyone, and welcome. It is Wednesday, the 18th of May, 2022, and you're joining the Knowledge Bolide Hangout, sponsored by Topher's Bay Meteorites. We're going to jump right into the meteorites today. The theme is kind of unique. It's like the trace minerals, the real rare minerals that are found in meteorites sometimes, and their terrestrial counterparts. So with that, I'm going to show you 5 quick meteorites, and let's just jump into it. Here is the first one, and I have it labeled so you guys will be able to tell very easily what it is. But this is the Admire Pallasite that was found in Kansas. And you can see in there, I have loose peridot. That's the space gems that we're going to be focusing. It's one of the space gems we're going to be focusing on today. And we're going to have Mike Kelly, our staff geologist, take us through Meteorite 101, Gems from Space. So he's going to talk about peridot, and just know that you've seen him now. Another thing he's going to talk about is Marjalahti. Does anyone know what's super special about this pallasite?
It's all crystal.
Yep. Well, yeah, this sample is pretty much like 95% crystal. Yeah. But there's something very special about that, about the olivine that's in this one that's not in any other meteorite. So Mike will educate us on that later on. But that's a witness fall from 1902. Mike is going to talk about sodium or chromium diopside crystals and what you're seeing there. But you can see right there on the right-hand side, that green crystal sticking out. Some chromium diopside in a piece of Lodranite.
Oh.
So we're going to learn about chromium diopside and different diopsides, as well as diamonds. And we're not talking about huge, multi-carat diamonds. We're talking about micro diamonds. But they're one of the places that they're found in meteorites is Ureilite. So this is a Ureilite that was actually given to me by Roberto Vargas.
Nice.
Yes, I agree.
I don't know how he got such an amazing finish on those, being harder than daylights.
They are ridiculously dense and very hard. And like I said, they do have micro or nano diamonds in them. So sometimes you can really, really have a hard time cutting them. So this is NWA 14451. And the last one I want to show you guys is super cool because there's a new paper that was written by Dr. Carla G, meteorite classifier, that is possibly linking this pallasite.
Wow.
They're potentially linking this in its planetary body back to the same planetary body as your Lodranites.
Oh, interesting.
So does anyone know the name of this pallasite?
I think I know it, but I can't say it.
Allison,
Is that Mark Lyons?
This is, yes.
Edmani something.
Nope.
Sorry.
Oh, then it's probably a different one you're thinking of. This is
Hesiel Boyd.
Exactly. This is
There
Hesiel Boyd 002. And it is a ungrouped pallasite. So they're doing more research on this one, and they're looking at the metal and also the olivines. The metal composition doesn't match other pallasites, and the olivines match those of, I believe, the Eagle Station pallasite. If I remember correctly, go and read the paper by Dr. Carla G. He's actually going to be presenting at the MetSoc on it.
Cool.
But it's super interesting to think that this and the Lodranite may have originated from the same parent body.
Wow. Yeah.
Wow.
That's cool.
That is a little bit of show and tell, hopefully to wet your whistles for some of the unique and special meteorites and some of the special things that can be found inside of meteorites. I spent a little time talking with Allison lately about something that she's doing, and it really speaks to me. And it's something that the Knowledge Bolide crew in general really, really expounds to do. So I'm not going to steal any thunder. Allison, tell us about what you're excited about.
Yeah, my meteorite display shelf is really, really empty right now because
Uh-oh.
more than half of my meteorite collection is on loan to my local high school science lab.
Oh, nice.
Oh,
Congratulations.
Yeah, I had mentioned a couple of months ago that I went up there and looked, and they didn't have any meteorites. I was surprised. And I told their science teacher that I would fix that. I was going to get them some meteorite. So I cut and polished a bunch of samples for them to keep in their lab, labeled them clearly. I gave them a big stack of Topher spin meteorite pictures to keep up there. And I gave them a couple of meteor wrongs that I've found locally. I was invited back in the spring when school starts again next year to visit with the rock identification class. And my boy will be in that class next year, so she's pretty excited to have him in the class. And maybe next year I'll send my meteorites to school with him, and he can give the presentations. So in the meantime, my rocks are up there. I left a bunch of my paperwork up there too, and encouraged the kids to just rifle through my paperwork and have a good look at the meteorites. So
that's fantastic.
Very cool.
Yeah,
Yeah,
Oh, that sounds great.
Very nice.
really exciting.
that is fantastic.
Yeah, they looked at them underneath of a microscope yesterday, and my son's friend was very excited that they saw silver in them, and I corrected her and said it's not silver. So I gave her a quick lesson, and like I say, I left them just all kinds of information where they can look into my paperwork and hopefully get online and do some self-educating too until I can get a chance to get in there and visit with them some more.
That is fantastic. Go ahead.
You've changed children's lives by what you have done.
Yeah, there were a few of them that were pretty excited. So
Yeah, it's a big difference to see them right in front of you or in your hand than online. That's
yeah,
great.
yeah. And schools are set up so nice nowadays. They have such good equipment that the whole class can look through the microscope together and they can talk about what they see together. So that's a leap and a bound from when I was in school and we each had to look through the whole, so
That's
I think
so
it's so cool. I'm excited for them. So
if someone had taken the time to do that when I was impressionable, young, and cool still, it probably would have changed the trajectory of my life. Because I honestly didn't know that you could own, I never looked into it, but I didn't really know you could own meteorites until, 4 or 5 years ago. So had someone came to my school and shown me something like that, it probably would have had a major impact in my life.
yeah, and I wasn't shy about sharing my paperwork with them either, so they can see what kinds of prices I've spent on them and where I've purchased them from and things like that as well. So
That is fantastic.
I feel very strongly that we need to support the science teachers. That's
yes.
Damian has done amazing work there, and good stuff.
Well, if anyone has any donations that they would like, any meteorites that are laying around, they don't have to be expensive and beautiful, whatever. If they're meteorites and you want to put them towards outreach, connect with me and I'll get them into someone's hands that is doing the active outreach like this. So Allison, fantastic work. Really proud to have you as a Knowledge Bolide crew member.
Yeah. I'm glad to be doing that with the kids. It's great.
Fantastic.
Oh, awesome.
Pat Brown, who has a strewn field in his house, and every once in a while he'll go to the far end of the strewn field and make a discovery. Pat?
So this is my reflected cross polarized light rig with a different well, let's see if you can highlight me there. Great, thank you. With a different lens on it, and we're going to look at some olivine. So what we're seeing there in reflected cross polarized light is a barred olivine chondrule. And barred olivine chondrules are pretty common. So what's so exciting about it? Well, this one is 19 millimeters across.
Wow.
Oh, huge.
Wow.
That's amazing.
It's far and away the biggest one I've ever seen. And it has some really so it's fractured in 3D here. It has some really cool detail, some finer barred olivine bands here, and then some much coarser ones in this lower area. So olivine is super common in meteorites of many different types, and it is the gemstone peridot, semi-precious gemstone on Earth, but it comes from space because this is the stuff that our planet is built out of.
Right.
Yeah. So I was doing a little decluttering here in the lab, and dug into a corner of stuff that I hadn't seen for a while, and so this showed up on my carpeted strewn field. This is 3.9 kilograms of meteorite.
Wow.
He just forgets about or misplaces a 4 kilo NWA.
Well, it's so small,
Yeah, and that's the that area right there is that.
Oh wow! Look at how huge it is.
And if that's on the outside, what's on the inside? That's what I'm wondering.
Well, so that's a good question, and so look, I've been studying this in the last few nights under the microscope. I get microscope time before I go to bed each night, and this one is a candidate type 3, so it'll eventually meet the saw, and we'll see what's inside. And Topper, if it's okay, I have a couple of photos to share too. I have a meteorite on the way. It's out of Africa and into Ohio, and now takes the perilous journey from Ohio to California with the Postal Service.
Pat, may I interject for 1 second, Pat?
Yes.
I would love, before you tell what you provisionally think this is, we get the crew's feedback if anyone has any guesses.
Okay, cool.
I think that's a fun thing for everyone. If you don't get it, it's not a big deal.
There's one photo here, that one. Look at that one. What do you think this is?
Carbonaceous?
I was going to say the same thing.
Okay, we have 2 people for carbonaceous.
Rumor Rudy.
Okay, we have a rumor Rudy and 2 carbonaceous. And Pat, can you go back to like the second photo, that one right there?
Yeah.
CK.
Major clue.
Yep. You see the type of crust? That's why I think it's carbonaceous.
Yeah.
Pat, is this a carbonaceous or a rumor Rudy or something else?
So this one, we think now, when one buys a meteorite directly from Africa, there are lots of bold proclamations about what it is, which sometimes are true. And this one was advertised as CK. So really nice, beautiful, black, shiny fusion crust that we can see here was wonderful contraction cracks. But the major clue is this surface. And note that the chondrules are quite black, but also the matrix is fairly abundant and very black. And so this one I think has a good chance of being CK.
On that one, on that like third to last picture, that one right there. If you go back, you can actually see chondrules coming through the crust. That's really nice.
Yeah, you can see some chondrules melted in half here in the fusion crust. Yeah.
Oh yeah, they're all flattened out where they're ablated.
Yes.
And can you show the internal for a second? I'd like to, people on YouTube who maybe haven't had the chance to hold a several 100-gram carbonaceous meteorite versus a stony meteorite versus an iron meteorite. The irons are easy, they're solid metal, but the carbonaceous, you could, if you were strong enough, if you were in a really manly mood, you could probably pulverize this in your hands.
Yeah, the CK meteorites, and now I'm making a leap of faith that it is as advertised. And I think, there's some chance it could be that or something more exciting than that. I don't think it's anything less exciting than that. But yeah, Stoper said these have the CAIs have the consistency of a charcoal briquette. And so the matrix is, and the chondrules are not really terribly well bound together. And yeah, if you had pretty good hand strength, you could break this in your hands, if it in fact is a CK. But look at all those pretty shiny little chondrules.
Yeah, those are amazing.
Yeah, can't wait to get this one in the lab to play with it. And
I'm surprised you haven't pulled one of those chondrules out with tweezers by now.
The thing that really got me on this one is this drop dead gorgeous crust.
Yeah.
This one's only 190 grams, so it's a little small for classification, and it's so darn pretty, I don't know if I can bring myself to cut it.
That is super awesome. That's a beautiful meteorite, man. Look at that.
Of the chondrules melted in half. Okay, Topher, thank you.
That is fantastic. Well, as promised, we are switching to one of our favorite segments here on the Knowledge Bolide Hangouts. This is Meteorite 101 with Mike Kelly. He's going to be talking today, as I mentioned, about gems from space. Mike, are you there?
Yes, I am. Good evening, everybody. Hope everyone's doing well. This was an interesting topic for me because I keep track of minerals in meteorites in all my pieces. But looking at it, I didn't really sift through and sort out, which are considered gem quality and which aren't. So one of the things I focused on here is trying to keep it to some of the more common things you're going to hear about. Topher mentioned kind of earlier before, folks talking about gold and platinum meteorites. And yeah, there's gold and there is platinum in meteorites. You're talking on the order of parts per billion to, if you're lucky, low parts per million. They've done geological research studies on meteorites before to see if they were, valid sources for things like gold and things like that. And bottom line is the majority of them don't have enough of those rare precious metals inside of them to be considered ores, worth going after. But there are some really cool minerals in meteorites that have equivalents on Earth that are gemmy enough that they are cut and turned into gemstones. And so these kind of focus on those more common ones you find on Earth that you also find in meteorites. So there are over 4,000 minerals out there that we know of in total. And of that, there's about 350 of those that are represented within meteorites. So there's a decent, almost 10% showing of all the known minerals within meteorites. Yep. And out of that, and I'm not done going through 100% of that 350 or so, but there's what I've run across so far is about 24 of those total out of 350 are considered gem quality on Earth. So what's wrong with saying, well, gems from space and, turning a lot of the things that we know that are gem quality on Earth to make gems from meteorites? And well, first of all, they got blasted off their parent body by a really large, hard hit. Mm-hmm. And then they floated around in space for a long while until they ran into something else that put them onto an Earth-crossing orbit. And then they ran into this big thing called the Earth, which is the third catastrophic hit in their life. So you're looking at a lot of shock event going on. And in general, shock is not something that is good for minerals to maintain their structure and stay solid. So although they are the equivalent of what we're going to be talking about on Earth for their gemmy equivalents, usually the chunks of minerals that we're going to talk about here that are found in meteorites are fractured to the point that you can't really get a decent sized gemstone out of them. So that's a great picture that Topher has in the background there. And you can see all the little fracture lines going through the olivines. So it is still olivine. It is still, the equivalent of peridot on Earth. To a degree, but you wouldn't be able to turn it into something that's faceted and beautiful because it would fall to pieces and you might get a tiny little thing out of it at best.
And even in the left-hand picture, that big slice or end cut of Admire Pallasite, you can see there's a lot of gemmy looking olivine in there, but if you tried to extract it, you just have chips. There's nothing, like it's been shocked and...
Yep. Diamonds, diamonds are a girl's best friend, and there are plenty of diamonds in meteorites. There are diamonds in several different types of meteorites, including the Ureilites, the carbonaceous, especially the CMs, and also in graphite and diamond inclusions within within irons. So the interesting thing about the diamonds are they are nano-diamonds. So this picture off on the right-hand side is a bit of Allende meteorite that they took and digested the meteorite basically by, soaking it in acid to destroy everything that wasn't, super solid. And basically, the only thing that survived that with the acid type they used is the diamonds on there.
Wow.
Now, what's really cool about the diamonds in these carbonaceous are these are interstellar diamonds. The isotopic ratios inside of them plot outside of the type of diamond you would create within our sun's photosphere. So these are little bits of trapped interstellar material within the Allende, and also Murchison has them too. So that's really interesting material to study because they're old and they're not from around here.
Wow, that's tremendous. When I was making this, when I was doctoring this slide up, I knew that there were found in little iron inclusions and also Ureilites, but I'll be honest with you, I learned something every week, and I did not know that Murchison and CMs included diamonds, let alone interstellar diamonds. So thank you, Mike. That was a great slide.
Canyon Diablos have black diamonds.
Yep. The next one is kind of a rare one. This is anatase. And so the only reason why I kept this one in here when I was trying to stick to most of the more common ones is because it's really rare on Earth, and it's found in a very common lunar that a lot of people have in their collection. So I thought people would like to know that. So NWA 11273, which is in itself a beautiful gem quality looking lunar with its beautiful nothosite in there, also has these little crystals of anatase in them, which is basically a form of pure titanium oxide. It's rare because on Earth, most of the titanium oxide forms a mineral called rutile, which is very common, but anatase is rare. Again, they do think that it's partially formed from terrestrial weathering, but just the fact that it's in there is kind of cool because you don't find it almost anywhere else on Earth anyway.
That's awesome.
Corundum. So corundum, we call that either ruby or sapphire when it's gem quality. Ruby if it's red, and sapphire if it's any other color, because it comes in just about every color of the rainbow. And it's basically a pure form of aluminum oxide. And this was a cool shot. It is found listed in 5 meteorites, but there's more papers out there that list other meteorites that have it in there. And this was a cool SEM shot because what it shows was a brand new mineral called Meteorite, named after Dr. Chu, who's a very big mineral expert. And he's got, I think, something like 3 dozen or so meteorite-based minerals to his name as far as being the first discoverer. And you can see this mineral, which is named after Chima, inside that little piece of corundum, which, as you can see, the little scale there is only about 6 or 7 microns across. So it's a tiny corundum grain, and it has an even smaller grain of mineral in there, which was a brand new find inside of it.
Oh, wow. That's really wild.
And it was named in honor of Chima. Spinel is the next one on the list. And this one's cool because it's in another exciting lunar. And we briefly talked about this before, but a lot of folks got Tissotine 001 in their collections. That's the hydrothermally altered lunar. And if you look at it, everyone was wondering, well, what are all those little red specks in there? Well, those little red specks are actually spinel grains. So that's a mineral that has a magnesium and 2 aluminums bonded to 4 oxygens. And it has that crisp red color to it. So when you look at your Tissotine pieces, especially if you look at them under the microscope, because the little red specks are usually pretty small, that's what they are.
Mm-hmm. And I really am thankful that a couple of weeks ago, we talked about Tissotine and we mentioned spinels. So I went to the microscope after the hangout and took pictures for people. But unfortunately, you really can't tell. Those are like crystals. It's not just red dye or anything like that. You can literally see the crystal structure, optically under the microscope. So I would almost recommend people, if you are interested in this, go out to the Met Bowl, search for the text spinel, try to find it in a meteorite you have in your collection, see if you can identify it in the slice.
Androdine, almandine, and pyrope. So these are all specific names for different types of what everyone is commonly known as garnets. So this garnet is a garnet from Earth but there are definitely plenty of garnets in the form of those 3 mineral types out in space. So again, that's one of those things where you don't really hear it listed in papers because nobody calls them garnets. You know, all the scientists are talking about them by their proper mineral names. So if you see those 3, that's what they are. Those are garnet found in meteorites.
You can actually see the shape of it in that picture.
Yeah. Yep.
That's crazy.
We get to olivine, everyone's favorite, probably the most common gemmy mineral in meteorites. There are 2 end members. There's a magnesium end member and there is an iron end member. And when we talk peridot on Earth, which is a gemstone, that is a magnesium-rich end member. So almost all magnesium in there, no real iron sitting in the structure of the crystals. And what's interesting is the peridot on Earth, it is all compared as far as its purity to the olivine in the fallen Pallasite that Topher showed at the beginning, Marjalahti. So that was considered the purest form, and that's the baseline for peridot. So just like we have a chunk of metal sitting over in the National Archives that is the foot or the inch, Marjalahti is the peridot.
That's freaking awesome.
So diopside. Diopside, we talked about in Erg Chech 002. It is a green, very, very vibrant, very green mineral. And again,
would that be a Kelly green?
I don't know. I'd have to look that one up. It does have a lot of hits in the Met Bowl as far as returns. If you search by mineral content, there's almost 500 of them. It's sitting at 453 right now. Erg Chech was really cool because whereas in a lot of meteorites, the diopside crystals are very small, the diopside crystals, which are chromium diopside in Erg Chech, are rather large and very, very clear and translucent when cut in thin slices. So Topher's got some great pictures off on the right-hand side there of very beautiful diopside that's atypical of meteorites.
And by seeing it in Erg Chech, I think for the first time, a lot of us were able to see chromium diopside crystals of that size in a meteorite that was, it's really rare, but it was very commonly being sold a few months ago and still currently. But it really helps once you identify in one of your samples, you can then very easily try to apply it or find it in other meteorites you have, which was the case of that Lodranite. I obviously recognized the crystal, did some research and found there's chromium diopside in there or diopside crystals in there as well. So what I really like about these 101 sessions is you can learn a fact, and if you remember it, you can apply it to other meteorites in your collection.
Certainly. Next one up on the list is jadeite, and that's exactly what the first part of the name sounds like. It's a form of jade, and it is only listed in the Met Bowl in 2 meteorites. But yeah, that's a very common sought after gemstone on Earth. So I figured it was worth putting inside this presentation because you might run across it in another one that you have classified someday. And then the final one on the list is opal. And this is relatively rare. Again, it's only listed in 4 meteorites in the Met Bowl. And interesting enough, that bottom one on there is an iron that had silicate inclusions and has olivine in it. And I do believe that one is like a couple tons, but it's still sitting and I think up for sale in Somalia. The image on the right-hand side is a SEM shot. And what was interesting there is those little pop marks around there are actually where they did laser ablation. So those little round circles are where they actually hit it with a laser to test it. And you can see the actual little marks the laser leaves as it vaporizes a little bit of the minerals.
Wow.
But that white speck right in the middle is actually a metal grain, and the rim around that white speck is actually where the the opal was found. So that tiny little rim around there was one of those finds.
That's crazy. When I was in Tucson, I saw some Ethiopian opal. It is just absolutely gorgeous, and it's very expensive, but this is like even way rarer than that. It's only found in 4 meteorites, and we're not talking about something you can hold, where you need a scanning electron microscope to view it.
Yeah.
And I think that's one thing that you've been mentioning it, and I want to reiterate, we're talking about trace amounts. We're talking about small microns, very, very tiny stuff, electron scanning, microscope viewing. You're not going to crack open a meteorite and find a, 6-carat diamond in there.
Yeah, certainly. I mean, a lot of the gemstones that we have on Earth require a lot of water in order to form, and they form what's called pegmatites and pockets in volcanic material coming up. And out in space, water is the rarity. So you get these things to form, but they form only on a very small scale based on what's available as far as the conditions. So it's a very macro condition they form in on Earth, and it's a very micro condition they form in up in space.
Fantastic, man. Once again, thank you for a great 101 session. Does anyone have any questions?
We now say, wow.
What? Yeah. Oh, wow. An exclamation of joy. Nice.
I have a quick comment. There's a brand new book in the Cambridge Planetary Science series called Meteorite Mineralogy that is wonderfully written and just an amazing book. It's definitely PhD level stuff and not a quick read, but wonderful.
Wow.
Hey, Pat, that book is co-authored by Chima, I do believe. I'll go pull it up in the bibliography and drop it in the chat. But yeah, that mineral, that macasite that was named after him inside that corundum, he's the guy who found them all, and he wrote that book.
Cool.
Oh, so
Wow.
it all comes full circle. Well, right now we're going to have Sue join us virtually. She's recorded the session. She's on the road traveling right now, but this is a new segment that we're really proud to roll out today.
Hi, I'm Sue Spinato, and I want to welcome you to a new segment that we just recently added to the Knowledge Bolide Hangouts called Conversations with Collectors. For our very first episode, I had the opportunity to interview a longtime member of the Knowledge Bolide crew, and I also made a new friend. Of all the wonderful qualities that this crew member possesses, the one that stood out to me the most was his resiliency. He has accomplished so much and has overcome so much adversity in his life. He is truly an amazing individual. This collector grew up in New England and lived there his whole life, with the exception of the time that he spent in the military in naval aviation as a jet engine mechanic. While in the military, the highest rank he reached was that of an E4 third-class petty officer. He even graduated in the top 10% of his class. During his younger years in the military, he was able to travel all over the world, including almost every country in Europe. And when I asked him how many countries he had been to, there were so many he couldn't remember the number. But what he fondly remembered was how much he loved visiting St. Peter's Basilica in the Vatican City. After proudly serving in the military, this collector was ready for a new adventure. He spent the next 25 years as a truck driver. He didn't drive just any old truck, though. He drove a Max 600 Elite. To give you an idea of how much power this machine has, it can haul 140,000 pounds. And that's roughly the size of about 85 full-size pallets. Imagine driving that truck around on the icy roads in New England. So, as if I wasn't already impressed with him, we then started discussing his hobbies. And they include photography, hiking, camping, kayaking, hunting, fishing, marksmanship, archery, just to name a few. There isn't really anything this collector hasn't done. Can any of you guess who this international man of mystery is yet? Topher, can I get a drum roll? With no further ado, let me introduce you to the Knowledge Bolide's very own Ozerky Turkey, Mr. Arthur Wagner.
So there you have it, guys. The nice little intro to our first segment of Conversations with Collectors. Sue has been reaching out to several of the crew members, having very lengthy conversations, getting to know them personally. And we're just trying to share the people behind the crew with you guys. So here's a little highlight of some interview questions that Art was able to answer with our time. So Art, thank you so much. And we all look forward to getting to know you a little bit better right now.
All right, thank you.
Through Cub Scouts, Boy Scouts was the enjoyment of the outdoors, where I enjoyed camping, canoeing, kayaking, and I did a number of years, 20-odd some years of kayaking and canoeing in the Great North Woods of the state of Maine. I've always had an interest in space and looking up at the stars and trying to identify the different constellations. At a very early age, I had an interest in both rocks and minerals, and this is a golden nature guide that was published in the 60s, and same with this is about fossils. I have rocks from space, and I would recommend this book to anyone who has an interest in space. It is easy enough to follow. It's not, you know, deep science, but enough to spirit you on to want to research more on your own. My club, known as the North Shore Rock and Mineral Club of Massachusetts, I have been in 23 years, which I joined after my military service. And so now, due to my health, it's been difficult. I've had to give that position up. And other interest I have is, of course, woodworking, and I do that for enjoyment, not for production work. I've also enjoyed photography, not that I'm a master at it, and I enjoy the microscope. And I was introduced to the microscope through a geologist in my rock and mineral club, who I would visit on weekends, and we'd get a pizza and we discuss rocks and minerals, but also meteorites. This geologist friend of mine was quite interested in meteorites, had quite a collection, many large-size meteorites that were way out of my price range, but we could also look at thin sections and such through the microscope that he had, and I've enjoyed that immensely. The LL3s are my favorite, but you know, to just say I'm all about LL3s and forget the rest, that wouldn't be accurate. So I'm trying to amass a spectrum of meteorites, from the ions to the stony ions and to the stone. I can't own them all. I never will, but that's all right. It keeps me busy. I've been able to learn from others in the group, and there are some very knowledgeable people, and I'm talking actual scientists, and you know, I can absorb some of it to a degree, but until you build a good base on terminology and definitions and how they're applied, it can be difficult. I can follow up to a point and then I get lost. So, but it's great seeing other group members, meteorite collections, discussions on the meteorites. It's just been great, and I'm very thankful to be part of his group, and thankful to all the members in the group for their sharing their knowledge and their meteorite collections.
Very good.
Thank you very much.
Thanks,
Yeah.
Art.
Thanks, Art.
You're welcome.
Yeah, thank you for your service, Art.
Oh, thank
Yes,
you,
thank you.
thank you.
You're our honorary Ozerki turkey and will be forever, man. We're glad to have you on the crew, and it was nice getting a little bit more detail about you and learning a little bit about your life and passions. So, and I will tell you, there's something very special going on with Sue. She is the newest member of the IMCA, the International Meteorite Collectors Association.
Yay, Sue.
Yes.
Hey,
Congrats.
I'm super proud of my little female nerd. She was making fun of me for a couple years being a nerd, and now I can make the same thing. She's a little rock nerd, but I'm super proud of her. There's, I think, less than 500 members of the IMCA in the world, and there's probably about 20 of them that are female. So congratulations, Sue. We definitely look forward to your continued contribution on the Knowledge Bolide.
Absolutely.
There he is, Smiley himself. What do you got
Howdy.
for us today, buddy?
Well, I got, I think this is going to be my new favorite piece here. This is, so this piece here, this was a piece that I recently purchased for my birthday from Topher Spin Meteorites. This is NWA 14743. And what I really, really like about this is I'm getting into carbonaceous, and I didn't have a piece that had CAIs in it that were really representative. And this thing is just nuts. Like this one here, if we come in a little bit, like this thing's about 1.5 centimeters in size. Like this thing's massive. And then just in general, this entire slice is just full. You can just get lost in all the different CAIs and whatnot. It's just absolutely amazing.
Beautiful.
What is, one more time on the classification? It's a 5, a C.
This is a CV Ox 3.
Oh, Ox 3. Okay.
Yeah,
So it
gotcha.
has the reduced oxygen.
So it's oxidized, so that there's CV3 oxes and CV3 reds, and it's basically oxidized or reduced. So oxidized is in a more oxygen-rich environment, and the metal is oxidized. Reduced is in an oxygen-poor environment where the metal is metal.
Thank you. I remember photographing this one, Jeff, and I could not get a bad picture of it.
No, it's awesome. It's absolutely awesome.
That big one right there, when I was taking photos of it, I would call that the ghost. It's just so amorphic. And then the one over there at 9 o'clock or 8 o'clock is just so white. It's just so homogeneous and white, totally different than the other one.
Super beautiful.
Can you give it a flip? I want to see the other side.
You betcha.
And I want to ask, I know you just went and looked at it with your blacklight. Did the CAIs fluoresce?
A little bit. I think I need a different lamp though. Because it was glowing all over the place a little bit, but nothing that would show up good under camera that I got. But
yeah, it's super hard to photograph the fluorescence.
That is a really, and I remember when I was photographing, I just spent an extra little bit of time with it because literally every time you zoom in, you found something new. Whether it was a different shaped CAI or some chondrules, because it's a 3, so there's going to be some good chondrules in there, but they're everywhere.
Yeah, they are.
Actually, there are some quite amazing chondrules in these. You notice that the dark spots that we're seeing there in the chondrules, those are actually little voids, and that's an indication of incomplete chondrule melting. And that oftentimes happens when there's a piece of relict grain in there. So it's material from the protoplanetary disk that, and all that had to come from someplace. And so that stuff we think came from outside our solar system or from whatever was here on this real estate before our solar system. But those voids in the chondrules are indicative of that incomplete melting and relic grains.
Fantastic.
very cool.
Thank you so much for that extra information. And Jeff, I hope you continue to enjoy this piece for a super long time, man.
You betcha. I definitely will.
Wow. Yeah.
So photogenic. So
yeah, that one really got my attention when I was when I was messing with it. And it's just, and it's a sizable piece. It's like 50 grams plus or something like that.
Yeah, 60.1 grams.
Whoa, yeah, nice.
Nice.
That is awesome. Thank you so much. I really appreciate you sharing that with us, and congratulations, man.
Thank you very much.
Stunning.
Next is Getty.
All
Hey, buddy.
right, good to go. I'm going to go back a little bit to Mike Kelly's talk, that fantastic talk about all the gemstones that we had. One of the ones that he mentioned was diopside, chromium diopside, and the meteorite in particular that he referenced was Erg Chech 002. Now, I have a few samples of this that I would like to show off. This is a 4.565 billion year old meteorite. It is the oldest volcanic rock that has been analyzed that exists on Earth. So that's pretty impressive detail about it. So most of it, this is an end cut that I have, a 9.27 gram end cut. But when we flip over, we see that we have a nice large crystal.
Oh boy, yes.
It's about, I think, 6
Green.
millimeter.
Very
That is a
beautiful.
beaut.
What was the size again, Getty?
I think it's about 6 millimeter long crystal there.
Beautiful.
So that shows, I don't have any of the very thin slices that show the translucency, but you can see kind of the depth that you get of this, and shows how clear these crystals are.
Wow.
Yes.
That is wild. And there's obviously those 3 big ones right there, but there's also more crystals in there as well.
Lots of little ones all over, yeah.
Are there any on the surface on the other side?
Nothing major on this side. Little kind of the general, I think of it as kind of like a quiche with little pieces of pepper in it or something. That's what it looks like to me. But you know, just the normal ones that you see on most samples. But I have one more. I have an individual here. This is a 3.69 gram piece, and the real showstopper on this one is the megacryst there, and that is about a centimeter long.
Wow.
And that is on the surface. Let's see if I can get
Beautiful.
focus. There we go.
Wow. That shows really well.
Beautiful.
See if I can rotate this and highlight it a bit differently.
Oh,
There
yeah.
we go.
Dang.
It's got a bunch of texture to it, depth when the light hits it right.
Absolutely. Doesn't get much better than that.
I'm very happy to have scored this piece.
Yes. So that's a great example of the chromium diopside that that Mike was talking about earlier, man.
Exactly.
Thank you so much, man. Super
All right.
appreciative of that
And
one.
if I may, a bonus. So I have one of those, an LL 3.1 in particular.
All right.
And this is
Oh, yeah.
Los Vientos 171.
Nice.
This was
Nice.
found in the Atacama Desert of Chile in 2016. It's very little weathering. It actually does have some fusion crust on the outside. And it is just, you know, as a 3.1, it's a very primitive chondrite. It has an absolute sea of chondrules, very light matrix, light chondrules throughout. There's this very large kind of beige off-white one.
Yeah.
And then just so many colors. Like
Look
you
at
can
how
see some
tiny they
reds
are up in
and
there.
browns, even some blue chondrules.
Almost no matrix in there.
No,
Yeah.
yeah, just all chondrules glued
It's just
together.
a sea of chondrules. It's fantastic.
Man.
Beautiful.
So if you like LL3s, this is
Absolutely.
a fantastic one.
Yeah, that'd be fun to photograph too.
It's a good one. It's a lot of fun.
Wow. Yeah, you did not overstay your welcome and you did not disappoint. Thank you, Getty.
Thank you very much.
Yes. thank
Really
you.
fantastic.
Beautiful.
Well, we had a really good show today about the gems, space gems, and different minerals that are rarely found in meteorites, but also have their counterparts here on Earth. So thanks everyone for your participation, and for Mike for his 101. That is all for this week, guys. We'll catch you next 2 weeks. Thanks a lot. Bye-bye.
Okay.
Bye.
Bye.
Bye.